Welcome to Networks Professionals.
Welcome to The Explainer. Today we're pulling back the curtain on the invisible mechanics that dictate whether your data absolutely flies across the globe in an instant or, dies a slow, frustrating death right there on the wire. We interact with computer networks all day, every single day, but we rarely look at the actual physical rules of the road that make our digital lives possible. So let's get right into it.
Why do modern networks stream flawlessly, while old ones crawled? It's a really high-stakes conflict between that laggy, buffering past we all remember and the seamless, instantaneous present of internet speed. We totally take for granted today that we can just pull up a 4K stream on demand. But getting to this point, it required a massive, fundamental shift in how data actually moves from point A to point B.
Think of it like this. Data travels exactly like vehicles on a giant network highway. If the roads are built wrong, well, you're going to get endless traffic jams. Our first stop on this journey back in time is the older, much clunkier infrastructure that defined early networking. It's a method of communication known as half-duplex.
Half-duplex is two-way data transmission, but it's limited to one way at a time. In this setup, network nodes must literally stop and wait to transmit if they're currently receiving data. It's incredibly stop and go. You absolutely cannot talk and listen at the exact same moment.
Okay, let's dive into this because the absolute best way to picture this limitation is the classic walkie-talkie. You press the button, you say your piece, you say over, and then you listen. If both people press the button at the exact same time, you just get this awkward, static silence. There's really no way around it. It's a fundamental physical limitation of sharing the exact same airwaves. And when you apply that exact walkie-talkie logic to computer networks, you run into some really severe drawbacks. By forcing all your network traffic through one single channel, you create these immediate, painful bottlenecks. Imagine a whole office trying to use one walkie-talkie channel all at once. It gets messy incredibly fast. Especially under heavy traffic, or when using old network hardware like those legacy hubs, having only one single lane for traffic going in both directions just bogs the whole system down completely. Now, this setup inevitably leads to one major problem: collisions. And hey, this isn't just a metaphor. Because the channel is unmanaged and shared, data packets literally crash into each other on the wire if two computers try to talk at the exact same millisecond. When they crash, the data is completely destroyed, the computers have to wait a random amount of time, and then they have to try sending everything all over again. As you can guess, this creates massive latency and painfully reduced speeds. But then came a massive leap forward, the full-duplex revolution. We went straight from stop-and-go dirt roads to a beautifully paved superhighway. This invisible upgrade is the exact reason you're able to watch this explainer right now in stunning high definition without an ounce of lag. The data just flows smoothly, continuously, and rapidly without ever skipping a single beat. Now, what's really interesting about this slide is how elegantly full-duplex fixes the whole problem. It physically separates the transmit and receive paths. By giving the outgoing data its own dedicated lane and the incoming data its own dedicated lane, it eliminates those nasty collisions entirely. They literally cannot crash into each other anymore because they aren't even sharing the same physical space. It's brilliant. The contrast between the two is really night and day. On one side, half-duplex is this frustrating single-lane bridge where packets are basically staring each other down to figure out who goes first. On the other side, full-duplex is a modern, multi-lane highway where traffic just flows seamlessly in both directions without anyone ever having to hit the brakes.
So the crucial point is this. Full-duplex doesn't just make the network safer from collisions. It effectively offers double the network throughput. Think about it. You have 100 megabits going out and 100 megabits coming in at the exact same time. This doubling of pure capacity is exactly what we need for today's high-speed, fiercely demanding network environments. Let's connect this abstract tech directly to your daily reality. Every single time you binge-watch your favorite show, or every time you hop on a crystal-clear voice-over IP call for work, you're relying entirely on full-duplex technology. Modern network switches and switched local area networks use full-duplex exclusively to power these heavy-duty applications. Without it, your video streaming would buffer constantly, and those voice calls would be full of drops and painful delays. Our modern digital life literally runs on this separated path design.
And this brilliantly illustrates the undeniable evolution of it all. We moved from old, noisy hubs dealing with constant collisions to intelligent, modern switches that eliminate wait times completely. Your speed doubles, latency absolutely plummets, and traffic flows simultaneously.
We shifted the performance impact from slow, high-latency waiting games to lightning-fast, zero-latency communication. It's a real game changer.
Which leads me to this final, very real question. Full-Duplex runs our modern world, but is a misconfigured half-duplex bottleneck hiding in your network? While half-duplex hardware is incredibly rare in modern setups, sometimes just a simple misconfiguration in your switch settings or, honestly, even a bad, damaged Ethernet cable can force your brilliant, high-speed devices to fall back into half-duplex mode. And if that happens, your data is suddenly thrust straight back into the dark ages of one-at-a-time collision-heavy traffic. It's an invisible mechanic, but it dictates everything. So check your settings, mind your cables, and ensure your data is always flying, never dying.
Thanks for watching.